Hi guys, welcome back to Learning Electronics Repair. So, having survived video 666, yeah, my 666th video yesterday, which was quite dramatic, we're back to continue with this. So, it's tomorrow already. This I have now repaired. This is a bit like sticky, it feels, this glue, but I think that'll hold together enough to test this thing. I mean, I did mention in the previous video that the speaker was given to me, really. The customer didn't want it, he'd managed to rip all the comb by abusing it with singing too loud, basically. So, we can put this back together. I'll just actually check this speaker. I should have done that before, actually, but you know, yesterday was one of those days, basically. It was just one of those days. The cone moves freely, so it's not seized up or burnt out in that respect. If it reads the right sort of resistance, it's a good chance of being okay-ish. I mean, I wouldn't give this to a customer, but for test purposes, it should probably be fine. What's it read? Yeah, 6.5. That's what you'd expect to see on the DC resistance of an 8 ohm speaker, because obviously it's inductive, so its audio frequency, it has effectively more resistance. Something's stuck on there, so we'll put that back in the cabinet. I had to move quite a bit of equipment to get my variac off the bench because the fuse on the input to the variac had actually blown up, so that comes from my isolation transformer into the variac. This has a 13 amp fuse, and so I'll show you what actually happened to this. Okay, so I think we can call that as one seriously blown fuse. This is vaporized, yeah, so there, that's what happened to the fuse. Okay, so that vaporized and spattered all over the glass. I don't have any more 20mm 13 amp fuses. I've put a 10 amp fuse in there. I mean, that's fine, to be quite honest. Probably makes more sense because the variac and the isolation transformer both 2 kVA, yeah, like 2000 watt basically. So I know there's some crazy calculations to do, but putting a 10 amp fuse in is probably better than the 13 amp, yeah. I will say, actually, I was a bit surprised when that blew the fuse because I'd just had it connected with the current limiting bulb, which sort of flashed and went out. So that's indicating to me that there isn't a short in there, so it should be fine, but in fact it wasn't fine. So in this case, the current limiter let me down. I mean, it wasn't connected when the fuse blew, but by the behavior of the lamp, it didn't tell me there was a short. So you would expect the light to come on bright and stay on bright, and it just didn't do that. It came bright and went dim. Okay, so we can debate that down in the comments below. I'm pretty sure the short is on the amplifier module, and effectively when the power supply powered up, it showed me that. With the current limiter, it didn't. It may have been that the power supply actually already tripped out, and with the current limiter on, nothing went bang. So yeah, guys, I mean, you know, this happens. Say what you will in the comments below. I'm sure I will have had plenty of comments on that previous video. All I'm saying is 666, yeah. Right, so let's get this back into the cabinet and let's test the amplifiers that don't blow up. I messaged the guy this morning to ask him what the problem was with these, but I haven't got a reply yet, so let's just connect them up with, I'll just stick some music in for now, see if we get some bass beats out of them or not. But before I do that, as I mentioned at the end of the last video, I just want to check when they powered up that there's no DC offset on the speaker output. Okay, so that's back together. This is just a woofer. I think it's what, 10 inch? 8 or 10 inch, I haven't measured it, but so it won't give a particularly good frequency response. This is just a bass port, but as I say, for testing these are working, that should be good enough. Speak-on connectors, so a handy thing to acquire, I think. I'll put it on the floor, give me some bench space. This is number 2, one of the ones that doesn't blow the fuse. I've just tagged a couple of wires. I'll put some clips on them actually. I couldn't crimp them properly, the wire was too thin, so I soldered them and melted the plastic things a bit, but hey, doesn't really matter. So before I attach my resurrected speaker, which I'm going to call Lazarus, I think, I'm just going to make sure there's no DC offset on the output of this amplifier. Now, normally you'd expect a protect light to come on in that case. There isn't a protect light on this, but there is a limit, so maybe that comes on solid for a protect fault, I don't know. So let's just have a look to see if we have any DC offset on here. And we don't. So it goes to 0, so that's what it should do. So the thing now then is going to be just to feed audio signal into this and see what actually comes out of it. So if I hear anything coming out of this at all, it'll just be the bass line. Let's just get a bit of music on just to see what it does. I'll go to YouTube for this. Okay, so I have the audio turned all the way down on the amplifier and on my mixer. Power it up. Blue light on. I'll put this to about half and I'll just turn the mixer up and let's see what we get. Well, that amplifier runs. I clearly can't test this as high power or even very loud, shall I say, but we say this one actually runs. I mean, I'm going to ask him what the problem was with this. I mean, do you think maybe he has faulty speakers in these cabinets and he's brought me the amplifier modules thinking they're faulty? I'm starting to get a lot more work like this now, and I think I'm going to have to invest in buying or more likely building some sort of load, like a dummy load, a dummy speaker load, so I can actually test these things. So I will have a look for that, but hey, I bet you guys can tell me a few things about that. So let's see what we can do in the way of building some sort of passive load, I would think it is. Best way to do that. I'll get the other one that doesn't blow up, and let's see what that one's doing. This is number 3, so same thing again. I wouldn't be surprised if it is also working. We'll just power it up, look for the DC offset again. No DC offset on this one. Let's try this as well. Okay, so the mixer's set down to 0. This is also set to 0 on the level on here. Power on, blue light. Give it some volume. Something might click, relay. Working. That's interesting. Well, he brought me these for some reason, but I think the reason is not faulty amplifier modules, to be quite honest. Let's have a look at that other one, the one that went bang. Let's see what damage was done to that, which may or may not have been self-inflicted, yeah? Okay, so this one, I've just disconnected all the cables from the power supply again. The first thing I want to know is if this power supply is still okay. Now, I'm going to put the current limiting light bulb on just to be sure. I don't want to be blowing fuses again because it was a pain in the butt moving two oscilloscopes to get to the variac so I could get it off the shelf, so I could get to the fuse in the back of it here. It does have a fuse at the front as well, but the one at the back blew this time. Okay, so we'll just check as well to see if the fuse in this, it does have a fuse as this blew also. Okay. Okay, so I have the power lead. Let's have a look. So no connection there. Let's go to the other one. Yeah, have a connection to there, and then from the other one to there. So the fuse in this didn't blow, only the fuse in the back of the variac. Okay, I have a fuse in the front of that variac as well, which is the one that usually blows, but for some reason it didn't. So effectively one fuse is on the input into the variac and one's on the output, and it's normally the one on the output that blows because it's the lower rated one. Okay. The next question then, does this power supply actually still work? Yeah. We'll see if the blue light comes on. That's probably a good start. So put the light bulb on. I'll put the camera where you can see that, so you can see what it actually does. Right. Plug it in. Switch it on. Let's see what happens. That power supply is blown, yeah. So obviously, whatever happens, which is going to be a problem on the main amplifier, has also killed the power supply. So let's have a look to see if we can figure out what's wrong with this. But it looks like on this, I'm going to have a fault on the power supply and a fault on the amplifier module as well. Okay. I might as well get both PCBs off here because I need to look at both of them now. And this one, there won't be any charge in the main capacitors because effectively there is a short somewhere. So they can't actually charge up. Yeah. Right, let's just take this apart. Okay, so here is the now defunct power supply. It seems like I didn't waste my time explaining to you guys how this thing basically works, although to be quite honest, explaining stuff to you guys is never wasting my time. To be honest with you, that's what I'm here for, and actually that's what I enjoy doing, yeah. So hope you guys enjoy seeing that. But anyway, we now have a dead power supply, and it appears to have a short probably on the input end because the light came on straight away. It's not like the thing sort of like powered up and maybe there's then a short on the output side. They behave slightly differently in that case normally, yeah, but we saw what the current limiting bulb did before. It certainly let us down in this case. So we have a destroyed power supply. Right, so let's have to see where this short is. The most likely place is directly across the input. Okay. And that's sort of, well, we'll go straight across the bridge rectifier, which is here. So this doesn't have any PFC circuit in. By the way, I'm thinking of doing it all you need to know about PFC to repair stuff video. You guys interested in that? But we can see straight away, in fact, we have a definite short here. Okay, that's across the bridge rectifier. Now, if we look at my original scribble on here, yeah, we're seeing a short from there to there. What's the most likely place that short is going to be? What's the most likely place? Well, there's two, basically. One is that the bridge rectifier itself is shorted. Okay, if that's the case, I wouldn't expect to see good diode junctions between the AC and the terminals. We can have a look. And the second one is that these transistors are both shorted because that is a path directly from here to here. Okay, it's so unlikely for these capacitors to be short. I'm not even going to consider it, but hey, that'd be the first time if they are. They both would have to be. And it's also not feasible really that one of these transistors is short and the other one isn't, because if this one was short, we would have a to DC basically 0 ohms route through here, but then we would have this capacitor and this one to ground. So both of these would have to be short and that would have to be short, and it doesn't again sound very feasible. So I'm confident enough that the fault is that both of these are short circuit. So now we're going to find out, and we're also going to find out if they are bipolar transistors or if they are MOSFETs. So I've switched to diode mode. First one, let's just have a look at the bridge rectifier. So the two middle terminals are the AC. One of these is the plus and one is the minus out. We can tell easily enough because this track goes to one end of this capacitor and it's the positive end, so we can say this is the positive output. So if I put the red meter lead on both of these, I should see a diode junction to here. And I do see a diode junction. And I do see a diode junction. They're slightly different. I'm not overly concerned about that, but bear in mind a lot of current is flowing through here. It could stress it. If we then go the black lead, we should also see a diode junction, but considering these are shorted anyway, what I'm going to see is I'm going to see from either direction a diode junction. That's because there's 4 diodes in the bridge rectifier. Okay, it'd be very unusual, in fact I can't really imagine how it would happen, that these diode junctions would read okay but the bridge would read short between the outputs. So that pretty much tells me that is okay. Yeah, as far as I can see so far, it's not likely. Capacitor, is it short? No. This is the junction between the two, and then from here to here, is it short? No, we're just seeing it charge up. Now we won't see a short here because we're reading from here to here and from here to here. And if both of these are short, which I'm expecting, these wouldn't read as short themselves because this point is isolated from ground there, yeah? Capacitor I mentioned. So we're not going to see a short across either of these, even if both of these are short. Okay, hope you can see that. Right, so next thing to the big transistors, which are down here, I know I'm going to see a short across them. Yeah. Short, all short, base emitter, collector, all short. And these, let's have a look. So these 2 transistors, we know they're going to be driven by this chip, the pulse width modulator, if you saw part 1. But it looks like there's a bit more circuitry here as well, which is connected around this. Diode, some resistors, another transistor. Looks like these go that way to there and to these. So I think most likely that these 4 devices, yeah, that's coming this way, and I think we can confidently enough say on the other side that goes to here. Okay, so it looks like those 4 drive these, and then they are driven in turn by this. So to have a chance to repair this, first of all we need to remove these 2 power devices and then have a look around the rest of this circuitry to see if we can see any other problems. There's no point checking these at the moment because of the shorts on here. Yeah, we won't get any sensible readings most likely. So I'm going to unsolder these. These could be tricky to unsolder with the vacuum tool because the legs are so thick. It is a double-sided PCB, so we need to get quite a bit of heat into this. Initially, I'm going to try and warm this up with hot air, not to melt the solder, just to warm it up, and then try and use flux and braid to see whether I can actually desolder them that way. I've unbolted the transistors from the heatsink, although what I will actually do, you can see they're still sitting back against the heatsink, so if I effectively try and move these forwards away from it, yeah, they have little condoms on to keep the tab on this shorted to that. Basically, they probably have metal tabs on. Let's have a look. Yeah, look, metal tab. So I'll try this technique of warming up and then braid. Let's see if this works. If this doesn't, we can try, well, we'll have to try something else because we need to do it. We need to get these out. So let's see. So that's got some warmth into the area. We'll add some leaded solder. Okay. We'll just try to do this one first. Bit more warmth into it. Oops, I think it was on the wrong one. Flux. Okay. bit more warm. Okay, let's have a look. I might as well add some solder on this one as well, see if I'm here. Okay, right, like that. This one. Okay, they're both done now. Right, what can we get off this? Let's have a look. So, yeah, that looks pretty good. I'm not sure it's off though. I'm not sure it's clear. Try not to dislodge this SMD resistor right next to there. Okay. Yeah, I think that might have been there. It's kind of like sealed itself back in again. There's still enough solder in there to actually hold it, I think. Okay, that might be better. Next one. Again, don't want to dislodge these little SMD resistors. Bit more. Might be clear, we'll find out in a minute. Oops, sorry, out of shot, that might be clear. What you don't want to start doing is trying to rip these transistors out of the board with any amount of force, yeah? Let's just see. No, it's not completely loose yet. But what I can do is try hook something like this into the hole in the transistor, the mounting hole, and then just effectively just warm these three up and it'll probably fall out. So just a little bit of pressure on it, not much. Let's see, will it just come out of here now? Yeah, that one I think came free. That one, this one, yeah, it's out. Okay, so there you go. So first one is out. There, it is a MOSFET. Let's get the other one out. I'll warm this all back up. That one isn't clear, but I think if I just heat them all up and get the little tool into the hole through the transistor again, it'll probably come out. Yeah. You might do that without using the braid, by the way, just hooking the transistor and warming all three legs up at once. But this did work last time, so we'll go with it. Okay. That one I think is free. That one I think is free. And this one just again. Okay. Still plenty of solder on this one. Okay. Same technique. Yeah, again, it's not just going to fall out the board, but if we just warm this up, it'll probably come out as easily, like the other one did. Yeah. Okay. You may find that easier by not removing the solder, by the way, and just heating up all 3 pins at once with a good chunky soldering iron and taking it out. We have our 2 MOSFETs there, IFPFZHDO. I don't have these, I'm pretty sure. I now have this horrible heatsink compound all over my fingers, by the way. Won't hurt you, just wash it off before you eat something, yeah. When we were working in the 80s, we called that stuff pigeon shit, by the way. That was the colloquial term for it. Short, 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 short. Totally short. And notice these are short to the gate as well. So that means there's every likelihood that high voltage has gone back up into this lot, okay? So we definitely need to check at least this and then see if this lot is also connected into that circuit, okay? Let's have a look at what we've got here. I'll see if I can get us under the microscope. First of all, I just want to know if these 4 transistors are all the same type, yeah? I mean, they could be complementary, NP type things, or maybe P-type, N-type MOSFETs. Let's have a look. Yeah, complementary devices of some type. G12L, G12L, okay, so they're not all the same. And this one, where is it? It's down here somewhere. There's another G1, okay, so we got some things we can look at here. Oh, there's a Zenith diode there as well, look at that. And this a normal diode. Okay, so we need to check the semiconductors in this area of the board. I may have to unsolder these, but let's have a look. So the outer 2 are the same. So if we assume this is the gate or the base, diode mode, what do we have? A bit of a strange reading. That reads like a junction. That doesn't. Okay, go the other way around. That also reads like a junction that way. Okay, so that reads like a junction in both those 2. Does this one read the same? Because it's the same type of device. Let's have a look. Yeah. Yeah. And then I think when I went this way around, I got a junction to there. And it does on this one, and this gave a strange reading. Yeah, so the fact they both read exactly the same strongly suggests to me they're both okay. And then these are probably complementary. So put the red on here instead of the black. Okay. Okay. This one. Okay. Okay, and then in the reverse direction, do I see a junction here? Yeah, like I did on the other ones. Yeah, also there. And then a strange reading. Yeah, I don't see anything on that one. And do I see anything on this one? No. So again, they both read the same as each other. I strongly suspect they're okay. They're connected via these. What are these? Oh! Oh! These are connected via this inductor. Okay, now this I think is part of the LLC, but it's also quite common for that to drive the output devices as well. That would protect the devices on this side from any high voltage or rather current flow in that way. So that's another good reason to suspect that these are okay. What is this thing here? What do we have here? Well, that reads like a diode all the way. Nothing. This is the Zenith. Should read like a normal diode in one direction, but a higher reading. See, 709, 445, and that reading 709. That is typical for a Zenith diode, and it's forward biased, so the reverse to the normal operation. So that is almost certainly okay. because of that higher reading. Then we have a transistor thing here. There's actually two, not one of these. So this one is a 2L. Okay, these are complementary as well. So diode junction, and then the reverse way, nothing. I can also test from the collector to the emitter. These two appear to be bipolar, if it's okay. And then this one will be the complementary. So black on here, diode junction, and then across here, probably read open. Yeah, so, and this might be like a diode, but doesn't. Okay, so comments, guys, but I think there's a lot of evidence here that tells us that these basically are okay. And if these are okay, then it's extremely likely that that is okay. Yeah. This one, diode, reads okay. We have some resistors here. These could be blown. These are right down by the shorted MOSFETs. So this one is a 10K. Oh, that reads like a short. That one is a 47 ohm, 470, so that's 47 and no zeros. That reads correct. That reads correct. That reads short. Now, it's not a normal thing for resistors to go short. Yeah. Where's that connected to? So that's the 47 ohm between the gate and source. That reads open, so there's no short here. Yeah, no short there anyway. I mean, the short's gone. That's the 47 ohms. Is that really a 10K resistor, or does it say E01? It's some different sort of code. No, I don't think it is. I think it's a 103. Why am I seeing a short across there? Why do I see a short there? Let me have a look at the same resistor on one of the good power supplies. I think that's the only way to really just figure out what I have there. Here's one of the good ones. I'll just try and get it at an angle where you can see it. Yeah, so R45 down there, that's the one that says 303 on it. I'll just try and prop this up. Yep, so we can see. So I'm on ohms range. Let's have a look at the reading on this resistor. See if this also reads like a short. So that's one end of it. I'll just try to get this where you can actually see where I am, so we know where we are with this. Okay. A little bit further down there. This is really tricky to do on camera, guys. Okay, so I'm on one end of it. Yeah, you can see I'm on one end of it, and this is the other end of it. And it is basically the same. Yeah, like 1 ohm. Okay. Slipped off it again. Yeah, so it reads like a short, the same as the other one does. So the mystery is solved. We know the reading is okay. But I'm very interested to hear what you guys think about why we have what appears to be a 10K resistor, which reads short across it. Very strange, unless it is an E01, and that means something else. So, nothing wrong with the reading across there, okay? In fact, it appears to be in series with this one, actually, if you look at it. It looks like it's in series with that one, okay? But we're not just out of the woods yet, because obviously a lot of current was flowing through this primary circuit, which blew the fuse and blew the transistors. And we know that was caused by some sort of short on the output. But there could be a problem on this part of the power supply because the current all flew that way. It all flowed. It all flew that way, okay? So if there's any damage on this side, it's going to be semiconductors, you would think, or low value resistors. Now, this is a bridge rectifier. These I thought on the first video were rectifier double diodes, but I didn't actually bother to check them. I'm thinking now, U3, U4, these are almost certainly like 99%. Voltage regulators, like a 7815 and a 7915. That's a 15 volt positive and negative regulator. They seem to go into this lot. This is the connections for the 15 volts, so we can look. And we can see that they are there. The capacitors are here. So these diodes are feeding the 15 volts plus and minus rails via these regulators into the connectors. Yeah, that's certain. Yeah, I will say 100% certain this time. This bridge rectifier is powering the main outputs. So I'm expecting this to go to one of these. Yeah, there, and then the other end to there. So we know that's powering that, okay? There's no short across the bridge rectifier. Now, let's see if the bridge rectifier tests okay. We might find something interesting here, because I said in the first video, it's strange, in fact I've never seen before, a bridge rectifier on the output of a switch mode power supply. And there's a good reason for that. So let's read this. So that's a capacitor charging up and it's not conducting, okay? So this must be the positive output end. And we see a diode junction, but look, 0.336. 0.336. So a different reading to what you would normally expect. It's not a silicone, it's not a silicon diode. Not silicone, yeah, it's not a silicon diode. Let's charge up. Yeah, 0.336. 0.336. The charging is through the big capacitors on the output, by the way. So there's going to be the short here because this is either end of the secondary. Yeah, and the center tap actually goes to there. So you expect that to be short, okay. This 336, and the reason I was surprised to find a bridge rectifier. You won't find normal silicon rectifier diodes, aka bridge rectifiers, on a high frequency switching power supply. It's because they don't switch fast enough. Yeah, you'll find Schottky diodes. A Schottky would read about 0.15 normally, these read about 0.33. And these, I'm confident enough, are fast silicon rectifiers. So they're kind of a cross between the two. They're very fast switching, but they're not Schottky, and they're not normal diodes. So that thing there is not a normal run-of-the-mill bridge rectifier. I can't see any markings on it, but you can have a quick look. But that is not a normal average bridge rectifier. That's a special bridge rectifier. Yeah, unfortunately I can't see any markings on it. But enough to say that if you ever repairing a power supply and you find a bridge rectifier which is faulty on the output on the secondary of a switch mode, do not stick like a normal mains frequency bridge rectifier in there, yeah, and expect it to work, because it won't, okay? Don't put one of these like mains frequency ones in, okay? So we have that. There's no shorts on that circuit, that tests okay. What we didn't test was these diodes, but the current I don't think actually went this way. So that reads like a diode. That reads like a diode. These will probably be the other way around. Yeah. Just go the opposite way. Reads like a diode. Reads like a diode. These will be like higher as they did with the other ones. So they're okay. Therefore, there's no reason to expect there's a problem with these voltage regulators, and with no reason to expect there's a problem on the plus and minus 15. But we're not out of the woods still, because what caused it to blow up? And the answer to that, of course, my friends, is something on here. Of course, the most likely something on here is short circuits in these devices. Okay, so to figure that out, we probably need to get this off the board. I could get probing down there, but it's a bit fiddly. We know there's a short somewhere on here anyway, so let's take this board off the heatsink. Okay, I have the amplifier board. You'll notice that these two have like these insulators on, and these were mounted with a plastic insulator here to stop the bolt shorting from the heatsink to the tab. The other one fell off. I've got it, but it's the same. These two are bolted directly to the heatsink, so the heatsink will probably be at ground, I'm guessing. I know it's at ground, so these tabs must actually be ground. Let's have a look to see what we've got. So we pretty much know that these are effectively like a high side and a low side. How do they read? So diode mode. This is going to be the gate. That reads like a diode. That reads like a diode. Are these MOSFETs? Well, they both read basically the same. Now, this is like the low side. This is like the high side. Now, this pair will be connected to that red lead, and we all know what happened in part 1. So, are these short? Yeah. So, they're completely short. So what's happened is when that red lead touched the output, it was on the right voltage output, but what I had at that time, I had ground. That wasn't connected, but this was bolted to the chassis. So I have a connection to ground, I have a connection to the plus, but I don't have a connection to the minus. And I have a suspicion these are going to be MOSFETs, let me see. And what's happened is, because I only had one voltage rail attached for an instance, they kind of like floated and switched on. It's just a feeling. What are you? Are you MOSFETs? Well, they've got to come out, so let's have a look. These should be somewhat easier to remove. We will see. Okay, the reason it should be somewhat easier to remove is because they're smaller and we can heat up all 3 legs at the same time and just take them out of the board. So just get hold of it, heat up all the 3 pins, and it should, yeah, just comes out, you see. Same with this one. This is not so easy with those big ones, although I did mention you could do them this way. So this was the technique I also mentioned with those. Okay, if you wondered what I mentioned, you know now. Right, what do we have? Are these MOSFETs? Oh, they certainly are MOSFETs. 23N20D. So I think what's happened here, guys, is that effectively I accidentally connected the positive supply and the ground by default from the chassis, and not the negative supply. And that in turn caused the MOSFET gates to switch on. Oh, look, that resistor there, that's gone. I bet it's gone as well. We'll check in a minute. And that's what shorted them out. All the current went through them. We were short. When I then connected the power supply, the light bulb current limiter didn't really help me because the problem was further down the line. And when I switched it off, it went bang. Okay, so we have a pretty good idea what's happened now. Question is, how far back did the damage go? So we need to probably change these two as well. I certainly wouldn't trust them. I mean, actually, you know what, guys? I would trust these because the current was going between positive and ground. The negative supply wasn't even connected. But having said that, this is ground. No. I'm talking myself in and out of it. I don't trust them. Okay, so change these. Change these. Where is this connected to? Well, that reads like a short. It might be a 1 ohm resistor. Resistors don't go low in value. You know, that actually reads okay. But, come think about it, yeah, that's a bit of glue. See, that's actually just a bit of glue, so that reads okay. That's a good sign at least. There hasn't been a huge amount of current gone down into the gate circuit. What drives it? Let's have a look. So, I can't see anything on this side of the board. I can see on this side of the board that they go this way. Okay, and we have almost certainly this is a pulse width modulator thing again. We'll look this one up, RS2092S or 5. Those come to here. I don't see any transistors in this area. Is anything on the other side? No. So I think we can probably say that this chip drives those, probably via a resistor or something. That's there and there. Where are they going? Down here. Which appears to be underneath here. Okay. That one. And another one somewhere. That one, okay. Let's just get a data sheet for this, but this drives these directly, so in my opinion, I should replace that as well. Let's see what it is. And here is the data sheet, IRS2092, protected digital audio amplifier. So this effectively is all the logic that controls the Class D amplifier, all the processing apart from the actual output MOSFETs here. So we see input, this is your audio signal, this does all the donkey work and it drives the MOSFETs directly. Because we know, we had a quick look around with the meter as well, that there is a connection directly between this chip and these MOSFETs, and we know these were short. It's most prudent, I would think, to replace this chip as well at the same time. They're not expensive, so I'll order some of these as well. But I don't think anything else will have been damaged. There are a few diodes around here, we can have a quick look. And I don't even know if the amplifier chip is damaged, to be quite honest. It's just good practice, I think, to change it given what happened. Okay, so let's see. Here's our chip, diodes. Reads okay, reads like a diode. This one. That reads open that way. Is that a diode or a capacitor? I can't easily see. I think it's a diode. Let's look at it this way. Yeah, it reads like a diode. One here is a diode. Reads like a diode. A few more resistors around here. That thing. Says it's a resistor actually. Okay. But again, it looks okay to me. So I think we can say we'll change this chip and we'll change those. And then we can try this again. Okay guys, well, some interesting techniques there. I mean, that's my way I would approach this. I'm guessing you guys may have some different ideas. I need to order some parts anyway, so you know what? It gives you plenty of time to comment, and if you feel there's something else I should do, we can do it, yeah, before the parts arrive. Okay, hope you enjoyed that, and I look forward to seeing you all soon on Learning Electronics Repair. Ciao for now, guys.